This video is a demonstration of how to use some simple geometry and our knowledge of navigation to fix a position. The scenario is given here in this question. So we have a map. This is the coastline with two landmarks, a tower and a church. We have true north given, and same as grid north, and we have a latitude scale here. Remember, every minute of latitude is the same as 1 nautical mile. So the first information we're giving is that the tower has a bearing of 090 true and the church is 135 degrees true. These recordings were taken from wherever the vessel may happen to be, so there's a boat somewhere here in the water, and they're recorded at 1400 hours. Now we don't know where the boat is, that's our job. So we have to imagine what would be the direction of the boat if you were at the tower looking back towards the boat. It would be the back bearing. Now, as previously taught, if you have a true bearing and you want a back bearing, you either add or subtract 180 degrees. In the case where we have angles less than 180, we add. In more than 180, we subtract. So adding here, we would get 270 degrees true as the back bearing from the tower. Well, how do I find that on my map? First thing first, I need to get a reference line through the tower parallel to true north. Easier said than done, but here's a few tricks. So I have a set square. It doesn't matter what shape set square we've got. I'm going to align that. I could use true north or I could use the latitude scale. Because this is longer, it'll be more accurate. Now I'm going to put an ordinary ruler at the bottom there. Hold the ordinary ruler firmly against the page, slide the set square across until it lines up with the tower, and I'll just put a vertical line through the tower. That's my reference mark, my reference direction. Here's my protractor. Put the centre point of the protractor on the tower. I'm aligning vertically on that line that I just made, so I know that the 0 degrees there is north and the 180 is south. Now I need 270 degrees true. From true north I'd have 0, 90, 180, and adding another 90 I'd be at 270. So I'll put a very small dot in line here with the end of the 90, and I can draw a line from the tower through that mark. That's looking from the tower at a bearing of 270 degrees true. The boat is somewhere along that line. I need at least two fixes, two sightings. The second one is the church. The church is down here. The church is at 135 degrees true. Again, less than 180. So I'll add 180 degrees. 5, 3 and 8 are 11, carry the 1. 315 degrees true. This is if I was standing at the church looking towards the boat, I'd be looking at 315. Same procedure. Use my set square lined up on the edge of the page there as well as I can. That's north-south. Put a ruler against the bottom of it, hold the ruler firmly, slide the set square across to intersect the spot here for the church. Draw my vertical line, that's true north. Bring the protractor back. Centre of the protractor goes on the spot for the church. The 0 of the protractor goes on that north line. Make sure they're both lined up neatly at the same time. Even a small difference here can make a rather large difference in the answer. Now I need 315 degrees. I've already got that it's 180 plus 135. So remember, north is 0, 90, 180. Using the inner scale, I need to go an extra 135, so that is here. from the church through the mark, and that is the position of my boat from 2 reference points. 3 would be better, but 2 is sufficient, and this occurred at 1400 hours, so I'll put 1400 on the map. Remember, from that point it looked like the person on the boat was aiming at 090 degrees in order to see the tower, and they were aiming at 135 degrees in order to see the church. We needed back bearings to get the direction from the church to the boat, from the tower to the boat. That is the first step. Now, a little bit later, at 14:30, half an hour later, the bearings were these numbers. So again, I need back bearings. These ones aren't so bad. I'll do these in my head. 30 plus 180 is 210. And that one's from the tower. I already have my north line. So I put my protractor in place. It's worth taking a little bit longer to get this lined up neatly. So we said 210. Remember, 180 is here, plus an extra 30 degrees. That's the spot there. And I'll mark a line from the tower down through there. From the church, the bearing was 90. Now, we already did a back bearing for 90 earlier. The back bearing is 270. So from the church, I already have my reference line for north. From the church, so that's neatly lined up, the zero's neatly lined up. 270 is due west. That's the fix at 14:30. So I'll put 14:30. And we know the time difference. That's part A. Fix the position at these times on the figure. Part B. Plot the course of the vessel and determine its true bearing. So now that we know where the vessel was here, travelled to here. I'll actually mark this one with an arrow because it indicates the direction of travel. That's plotting the course. Determine the true bearing. Well, I will need a reference line through this point. So I'll start with my set square. Nice and straight on the edge of the page. Put the ruler at the bottom, slide across to the first fix. There's my reference line for true north. Put the protractor in place. So remember, using 0 as north, we're at 90. That's not quite straight. That's better. 90. Now here's the one that I'm looking at. This is more than 150. Looks about 156 according to my diagram. So I'll say that for part B, we are heading at 156 degrees true. Part C, how far has the vessel travelled? From here to here. There's a couple of ways you can do this. I could measure the distance with my ruler. Now, being as careful as I possibly can to line up the start and the end, it looks to be 61 millimetres. 61 millimetres is not really the unit I wanted to work with. So I'm starting here at 28 degrees and I'm going to run down to 61 millimetres, which is there. Remember, every one of these minutes is a nautical mile. So I'm at just a smidge under 7.4. I'm going to round that to 7.4. So the distance travelled 7.4 nautical miles. Part D, what speed is the vessel travelling? Well, I know the distance covered was 7.4. I know the time between these was 30 minutes or half an hour. So speed equals distance divided by time. 7.4 nautical miles divided by 0.5, half an hour, and that comes to 14.8 nautical miles per hour is the knot, the unit of speed used in ships. Finally, at 14:30, how far is the vessel from the church? In other words, the distance directly from here to here. Once again, I'll demonstrate a different method this time. If I don't have a ruler handy, I can quite literally mark the distance between the 2 points on the edge of a sheet of paper. Compare those 2 marks with my latitude scale, remembering that this is 28 degrees 0 minutes. 1, 2, 3. I'm going to estimate between 3.6 and 3.8. I would say 3.7 nautical miles as my determination for the distance between the church and the boat at 14:30. That's how you fix positions on a chart using 2 reference points.